Shall we start? It is my great pleasure to introduce my last student at BU, Johann. Sebastian.
Say best for last.
They're laughing. I don't know what it is, but anyway.
Oh, he does?
Yeah. Johann came from Chile and got a merit-based Coley and an international scholarship. I went to McAllister College at Minnesota for a bachelor degree, and came to BU, joined my lab in 2006, 2007, right? So that's right. He's a phenomenal student. He does many different things. I will see what he likes later. But you know, he got at 2009 he received pre-doctoral breast cancer research grant from DOD. And 2011, which is last year, he received Graduate Student Outstanding Service Award from BU, and the second prize from Russick Student Achievement Award from BU School of Medicine. At the same time, same year, 2011, he received Distinguished Poster Award from a DOD Era of Hope Breast Cancer Conference. So he's a quite phenomenal guy. He loves many things. He loves rugby, which he broke foot or arms 3 times, 2 or 3 years, 4 years. He loves travel, and last year, 2011, he traveled with me to Lyon, France, and many other places, including in the future China. And he likes beaches. He goes to beaches all the time, not during winter time. He likes food, Italian food, Spanish food, Chile food, everything. I want to say he loves dating, but I'm not sure. but most of all, he loves science. You know. He has done a very phenomenal studies. That's here in the rural P63 in cell migration and cancer metastasis, in which you will find he discovered a new pathway how P53 family member P63 regulate proliferation, metastasis, migrations here. You can see how he uncoupled, discovered how P63 regulate MAP kinase pathway. One thing I forgot to mention, he's a very social guy. He takes a lot of social responsibilities. He is a co-founder of the BU chapter, University Allied for Essential Medicines, which I know a little bit about it, and not much. He is a biochemistry student organization chair for a number of years. And as you can see, he received outstanding student service, right, last year. So without further ado, again, he's last student of my career at the BU, PhD student, I mean. And he will be my first postdoctoral fellow in Sichuan University in China, which is top 10 university in China. Welcome to China, welcome to your future. Thank you. You will get your degree here.
Thank you, Jim. Thank you also for not talking about my previous dating experiences, since my girlfriend is here. And thank you, everyone, for coming to my defense seminar today. I'm going to tell you about the research that I have conducted over the last couple of years that involve the role of the P53 family member P63 in cell migration, invasion, and cancer metastasis. Cancer is a devastating disease. It affects millions of people in the world, and it has a very high incidence of over 13 million new cases being diagnosed every year. In the United States alone, with a population of about 311 million, there are over 1.5 million cases diagnosed every single year. In China, with a population of about 1.3 billion, there are over 3 million cases of cancer being diagnosed every year. And in a much smaller country like Chile, with a population of only about 17 million, there are about 38,000 cases of cancer being diagnosed every year. That means that for those of us that live in the United States, in China, or in Chile, there's about a 40% probability of being diagnosed with cancer at some point in our lives. Cancer mortality is also quite high, and it is highly dependent on access to early detection methods or to therapy. However, even if detected very early, the majority of cancers don't have a cure and cannot be treated properly, thus making cancer one of the leading causes of death in the world, accounting for over 7.5 million deaths every year and rising. Thus, it is absolutely important that we focus as many of our resources as we can in order to understand this disease better, so that we can design better therapies, more effective early detection methods. From physiological point of view, cancer arises from the accumulation of mutations that promote survival and proliferations on a single cell. So now I'm going to use this example of a simple columnar epithelium to explain cancer progression in a solid tumor. However, bear in mind that other kinds of cancer, like leukemia, follow a different progression model. So when these cells accumulate survival and proliferative mutations, they can go on to divide uncontrollably and can create the growth of a new tissue or a neoplasm. If this neoplasm is detected early enough, it can be extirpated by surgery, and you can halt cancer progression right there. However, if it goes unnoticed, cells can continue to proliferate, and the tumor can grow larger. If it invades through the basement membrane, it becomes an invasive carcinoma. Invasive because the cells invade into the underlying mesenchyme, and carcinoma because in this example we're talking about a cancer derived from an epithelial cell. As the tumor becomes larger, the cells in the core of the tumor don't have enough access to nutrients, and they can die, thus releasing their contents onto the extracellular matrix and causing an inflammatory response, thus recruiting inflammatory cells like leukocytes, macrophages, or granulocytes, in addition to fibroblasts from the underlying stroma. These cells then secrete a variety of growth factors and cytokines that make the tumor grow even larger. The tumor can now even direct the formation of a new vasculature, which will then supply the tumor with nutrients, sustain its growth, and it can also serve as an avenue for cells that have acquired migratory and invasive characteristics to escape the primary tumor by a process called metastasis. Metastasis accounts for over 90% of cancer-related deaths, and it is the process by which cells escape the primary tumor, enter circulation, travel in circulation, extravasate into distal sites, invade through the connective tissue, colonize a new site, and grow as a metastatic nodule. These nodules can grow into fully grown tumors as a secondary tumor, and this, from a clinical point of view, is extremely important because once cancer has disseminated, it is virtually impossible to remove all cancer cells by surgery alone. Because even if you remove the primary tumor and any metastatic growth that you can see, there can be many micrometastases that can then grow into a fully grown tumor, and they can also metastasize again. In the case of breast cancer, common sites for metastatic growth include the bones, the liver, the lungs, to which I will refer later in my presentation, and even the brain. From a molecular biology point of view, there are two main events that need to occur for a cell to become cancerous. One of them is oncogene activation, whereby oncogenes like RAS or MYC or receptor tyrosine kinases will direct increased cell cycle progression and will enhance survival so as to promote cell proliferation, growth, evade apoptosis, etc.